Hello, welcome to CNET124. My name is Jason Carmen, and I will be your professor for this course, which is, of course, Introduction to Networks. Now, normally our lecture will be synchronous, meaning we'll be meeting together in the physical classroom on... hold on, let me take a peek. I don't remember when that class is. Just a second. Back. Sorry. So that's we'll be meeting together for our lecture on Tuesday morning at 8:30 a.m. And of course our lab class is Friday morning at 8:30 a.m. Now this time wasn't in my timetable until sometime yesterday, being Wednesday afternoon. So I wanted to get this done as soon as possible, and this is the earliest opportunity I've had to do it. I'm going to provide your week 1 lecture as a video to watch. So this is the only lecture video you're going to receive for the semester. And then next week on Tuesday we'll meet as scheduled at the 8:30 time slot and be able to work on week 2 stuff. As far as week 1 tomorrow goes, I mean, if you are able to see this before class tomorrow, excellent. If not, it's not the end of the world. I'm going to direct you to watch this anyway, as you will discover having watching this after the fact. Yeah. A little bit about me before we get too underway. I am a professor at Centennial College. I've taught this course several times now. I'm very comfortable with the material. I've been teaching at Centennial for going on 5 years now. And I also teach CNET124, which is Introduction to Web Design, Microsoft Office. This semester I'm also teaching CNET102, Introduction to PC Operating Systems. So you may or may not have me for that. I don't know. I haven't glanced over my class list and compared. And I am also a professor at Seneca College, from where I graduated, and I'm teaching ULI 101, which is Introduction to Unix, Linux, and the Internet, and OSL 640, which is a course that I actually developed this summer. It's brand new this fall, and that's Introduction to Open Source Systems. So I'm pretty busy. I also, as I know all of you are learning from home remotely, I am teaching remotely from home. So you may hear, even in recording this video, but definitely in our class sessions, outside noises, from my stepkids who are upstairs, my 10-year-old son and 12-year-old daughter, who are online schooling, and they both hate it, especially my son. He tends to complain it quite vocally. And also my 5-month-old daughter, who, there may be noise from time to time. Also, I have a Beagle Basset Hound cross named Gemma. She's 11. She can be pretty vocal at times, so you might hear her bark in the middle of a video or in the middle of a lecture recording. It is what it is. I apologize. Hopefully it's not too disruptive. And my other dog, Bo, who's a wire-hair Jack Russell Terrier. He's like 14. He's like old, barks at everything. But not quite as loud as the Beagle Basset Hound, who her bark could wake the dead. So there might be interruptions. I apologize. I know you all also may have interruptions. So there's that. I would normally at this point go over the layout in eCentennial with you, but I haven't gotten a chance to set that up yet. I'll be doing that after I record this video, and obviously before your class tomorrow, so you will be seeing this and that at the same time. I will have, if I haven't done it by the time class is done tomorrow, I won't have it done by the end of this video, I will have all of your lab due dates pre-entered into eCentennial, so they will pop up in your calendar every week. Additionally, we'll be using the virtual classroom and there'll be a link and a notification going out about that a wee bit later. We're going to meet using that virtual classroom link twice a week. You can access that through the calendar on the kind of the side on eCentennial. And your labs are going to be due 2 weeks from the assigned date on the Saturday at 11:59 p.m. So that should give you plenty of time to get them done. Don't panic. As far as submissions, I don't need anything fancy. If there is a packet tracer file, we will be using packet tracer this semester for everything. If there is a packet tracer file that results from the lab that you have done, that is the submission. And if you haven't, there's a couple that don't. The first one is one of those, and also there's a Wireshark lab later in the semester where there's no actual anything in packet tracer. Just take a picture of the written answers in the book. Speaking of which, 2 questions I always get: do I require the textbook? Well, the answer for this one is no, you don't. There's a link, or will be a link in eCentennial to access that book. And do I need the lab manual? And ideally the answer for that is yes, but I will see what I can do about providing you the appropriate materials as needed. If you can get yourself a physical copy of the lab manual, normally the standard policy is we require that. So be aware there is that expense. If you're picking that up, note as with the sides, or as with the slides, it is the Intro to Networks version 7 curriculum. Don't get the version 6 curriculum. It doesn't have the stuff we need in it. So, with all that in mind, let's get underway here, shall we? So we're going to look at, today we're just going to look at some broad network topics and all of these things here, how we use networks, how they work, that sort of thing, and a little bit about security. And you're going to get comfortable with all of these things as we progress throughout the semester. If you're feeling a little intimidated because, oh, Cisco's scary and I've never done that before, don't be. Don't be at all. I'm a Seneca graduate from the 3-year networking diploma. I had never used Cisco before I went to Seneca, and, well, here I am, teaching it now. And not for the first time, I might add. I've been teaching it on and off since 2015. This should be no surprise to any of you. Networks connect us, right? Everything we do now, whether it's streaming video, especially in light of the pandemic, remotely working, remotely learning, gaming online, ordering groceries, ordering food. We do everything online, right? How does that all work? Networks. Without a network, and without the internet, which is a network of networks, it wouldn't work. So the internet as we know it today has sort of created the illusion, anyway, of a world without boundaries. We've got global communities, various different gaming, and if you get involved in the open source community, a lot of forum and online-based discussions happen, and collaboration even on open source projects where people don't necessarily meet face to face, but they contribute to the same project and it grows over years. And they could be working with each other online for years and never meet. And we always have to remember too that at the end of the day, we're connecting people. We're not just connecting a bunch of servers and a bunch of computers for no reason. We're connecting them so people can do things, whether it's their job, entertainment. There's always a reason behind it. So, yeah, without the people, there's no need for it. Now, networks consist of various components, which we can broadly categorize into 2 roles. We have hosts, and end devices, and network equipment. So hosts and end devices consist of client PCs, servers. So servers provide us things like email, web servers, file servers, and a variety of other things too. Clients are any device that requests information from a server. So in terms of thinking web server for a second, when you open a browser, whether it's on your smartphone, tablet, laptop, desktop, doesn't matter, smart TV I guess too, anything you open a web browser with, and you type in google.com, you hit enter and you see the page for Google appear. Well, you're actually connecting with your web browser to a web server that's returning, and there's more to it than this, but it's returning the source code for the web page in HTML format, and that's interpreted by your browser, and you access it in the form of a web page. That's kind of how that works. We'll look at that a little more later in the semester. Everything's kind of this client-server model to an extent. We could also have peer-to-peer networks, and we use these all the time. Certain game companies like Blizzard deliver their software updates, and when you're downloading software from Blizzard, you're downloading partially from Blizzard servers and partially from peer-to-peer as well. They've integrated that within their patching system, and some other companies have done this as well, but I know of Blizzard offhand. We also use peer-to-peer networking in terms of legal and not so legal uses for torrents, and I'm sure you've all used a torrent. So in a peer-to-peer network, every single device is simultaneously both a client and a server, and they fulfill both those roles. They're pretty easy to set up and relatively easy to use. The downside is that there's no centralized administration. They don't scale very well. They're not particularly secure, and for any complex tasks, they have pretty poor performance. They tend to be pretty slow. So we have in here we have the concept of end devices. This is what makes up a network. End devices are anywhere that data originates from or is received. So your smartphone, your computer right now that you're watching me on, or tablet, or laptop, or whatever you're watching me on, is an end device. My computer is an end device. Servers are end devices. Anything that connects to a person or doesn't connect to another piece of networking equipment, doesn't extend the functionality of the network, is an end device. Extend, not too crazy about my wording there, but it is what it is. If we want to extend and expand our network, we need what are known as intermediary devices. So these are pieces of networking equipment that connect our network together, and we're going to learn about how to configure all of these in this course this semester. Not necessarily all of them, because I don't think we do much with wireless routers. But things like switches, routers, multi-layer switches, we're going to be using those three for sure. Firewall appliances, not so much, but they exist quite commonly in industry, but we won't be configuring those this semester. That's a little outside of the scope of this course. Network devices are connected through various network media. You have to have some sort of medium to send the signal. Everything in computers is spit out as a representation of binary somehow over some networking media. You could have copper Ethernet cables, which are, well, the copper is the metal wires within the cable itself, and those use electrical impulses to transmit ones and zeros. We're going to learn more about that in a few weeks as we look at the physical layer of the OSI model. It could be glass or plastic fibers in terms of fiber optic cables, and those use light pulses instead of electric pulses. which is partially why fiber optic is a lot faster. And it can also be wireless, which we are all very familiar with. Everybody has a wireless network and wireless device in their house and probably in their hand as we're speaking right now. And those use wireless as a medium for transmitting data. So we use all of these things, and we're going to look at how they are represented both in terms of Cisco Packet Tracer, which is what you're going to be learning to use in our lab this week, and also in the Cisco documentation. Cisco has particular icons that they like to use for these things. So in representing network topologies, we have particular, which is just a fancy word for a network diagram. We have particular symbols to represent different devices in the network. And when you're using Packet Tracer, you can find these devices in these categories within the actual software. So we have things like end devices, which we just sort of talked about, right? That's your desktop computer, laptop, printer, all these things too, IP phones, servers. We have intermediary devices. You're predominantly going to be dealing with routers and switches, but you might have multi-layer switch, wireless router, or firewall appliance up here. And we also have our media represented. So local and wide area media and connections appear like that in Packet Tracer, and wireless appears with this this funky little squiggly line. Some important terms to note that you're going to learn about this semester are our NIC, or Network Interface Card, and that is anything in your computer or device that provides a port is a NIC. Physical port is the actual port itself, and we tend to refer to these in the Cisco syntax and from the command line as interfaces when we're programming and configuring these. You may see, just going to note before we jump ahead again, you may see port and interface used interchangeably. And you probably will. I probably will end up doing that too. When you're looking at network topology diagrams, those can be looked at in two different terms. We can have an actual physical topology diagram, which looks more like this. It consists of all of the technical details, and all of the devices are labeled. So, for example, this is rack 1, shelf 1, rack 1, shelf 1. This is rack 2, shelf 1, and so on and so forth. Or you can also have logical diagrams. These ones tend to have more details about the IP addressing and how things are clustered logically in terms of departments and groups of people working together and such. These ones are more in terms of the physical layout, how the cables are installed, how things are connected, and they're two different ways of looking at the same topology. Common types of networks, well, we have networks of all sizes nowadays, right? Everything's a network. And the internet itself is, Vint Cerf famously described this, who is considered to be by many the godfather of the internet. Vint Cerf has described the internet as a network of networks. That's all it is. It's just a giant network of networks. So we have many different size networks. We have small home networks, so these connect a few computers and each other and to the internet. We have small office or home office, so this is slightly bigger, but you're looking at a computer or computers within a home or remote office to connect to a corporate network. We're kind of using both of these likely right now in terms of our work and education, as COVID has really and the pandemic has really underlined the ability to work from home and the need for better resources for doing that, right? And who knows when we'll be returning back on campus. It won't be this semester. We have medium to large size networks, so these are many locations with hundreds, if not thousands, of interconnected computers and devices. Centennial College, with it's got 4 campuses, if I recall correctly, could be an example of this. We have all of those campuses are interconnected. All of the devices on those campuses are interconnected. That is a medium to large network. And then, of course, we have worldwide networks. The one you're more commonly familiar with, I already mentioned, is the Internet. But we may have other large organizations that span the globe that have their own private network that's not necessarily connected to the Internet, but is still connected and spans the globe. Companies like Cisco and Microsoft have things like this set up. They're not all necessarily publicly accessible. So when you're looking at networks, they're the way they're built, the way their infrastructure is built, and you're going to learn a fair bit more about this in a later course. We actually get to design some networks. They all vary fairly greatly in terms of the size they cover, the number of users that they include, the number and types of services that are available on the network, and how they're configured, and the area of responsibility. And when I'm talking about number and types of services, you might have a mix of Windows and Linux or Unix servers. You might have pure Windows server environment. You might have a pure Linux server environment, but more commonly you're going to have a mix of both. Two of the most common network types that you encounter are local area network, or LAN, and wide area network, or WAN. So LANs are simply they're a network that spans a small geographical area. Your own home network is a LAN. Think about it, you've got probably smart TVs, game consoles, laptops, tablets, smartphones, maybe a desktop in there or two, possibly a printer, I know I do. All of these things are connected, and various other smart devices too, but they're all connected to your router. And some of those have access to share resources outside. All of them, of course, have access to draw resources from outside. And that's a LAN. That's a good example of a LAN. WANs are networks that span large geographical areas. A good example of this is in Toronto. The TTC has a WAN that connects all of their back-end infrastructure together. So these are interconnected over wide geographical areas. They're usually administered by one or more service providers, and they tend to provide a lot slower speed links between different LANs, because there's a lot of data moving back and forth. So the Internet is a connection of networks. I already kind of mentioned that, right? We have various LANs that are connected to each other using wide area networks. And these wide area networks may use copper wires. They might be fiber. They might be wireless transmission. It really depends. But the Internet itself is not owned by any particular individual or group. We often think of Google when it comes to in terms of the Internet, but they're not the only. They don't own the Internet. They just happen to control the flow of a large amount of traffic, scarily large amount of traffic. But we have a couple groups that help develop and maintain the structure of the Internet. And these are the IETF, which is the Internet Engineering Task Force, ICANN, and the IAB. So intranet is another type of network that we haven't really talked about. An intranet is a private collection of LANs and WANs internal to an organization that's meant to be accessible only by that organization itself and members within that organization, and possibly other people that you've allowed access to, such as a supplier or something like that. Extranets organizations might use to provide secure access to their network for individuals who work either for different organizations or possibly for themselves too, that need data or access to data within their network. I'm going to pause again for a second. So we already kind of talked about how the internet is a variety of networks that are interconnected, but the openness and the ability, the methods to connect those is, well, worth mentioning and worth talking about. There's various different ways to connect organizations to the internet. You could have, for example, broadband cable or DSL, depending on your internet provider. You could have a wireless wide area network connecting you to the internet. And you could also have mobile services, which you have in terms of your phone. Organizations themselves, if they're providing VoIP and video conferencing and large quantities of data storage, they need much, much faster connections to handle these sorts of things. So they will use business class, business grade internet connections. And these are usually provided by a service provider and may include business DSL, leased lines, and Metro Ethernet. For your small and home office connections, we're generally looking at this variety of things. Cable and DSL being two of the most popular. So cable and DSL are always on high bandwidth internet access. Cable being provided by usually providers who also provide cable as a service. And DSL runs over a phone line, so these are usually your phone providers. Examples of these in Canada anyway, for cable you're looking at Rogers. For DSL you're looking at Bell. Or alternatively you can go through a third-party service such as TechSavvy, but their back end runs on either Rogers or Bell, and TechSavvy does offer both cable and DSL. They're the provider I use. I think they're great. I highly recommend them. Outside of those, you have cellular connections. So if you've got a cell phone that has a data plan, that's on a cell provider's network. You may have satellite network, depending on where you are. These tend to be rural locations, and this tends to be fairly expensive, and the speed isn't great. It's not a great trade-off. And alternatively, you might have dial-up, which is even less commonly used, but it still exists. Dial-up's been around for a long time. I remember in the 90s we had dial-up internet. And this is fairly inexpensive, low bandwidth, very, very low bandwidth. And of course the downside to dial-up is it ties up your cell phone line, or your cell phone line, your telephone line while you're online. And yeah, in the 90s, that's how we surfed the internet, was dial-up. It took 45 minutes to download a song. It was really slow. So when you're looking at business connections, these are generally for corporations, but they could be medium-sized businesses too, I imagine. They require a variety of things. They require higher bandwidth, they require dedicated connections, they require managed services. Because if you're a business, you want especially in this day and age, you want any of your content that's accessible on the internet to be always up, 24/7 uptime. Any service disruption means lost money, lost revenue, and people are going to complain. So we don't want that. These may use dedicated leased lines, Ethernet WANs, business-grade DSL, or even satellite for remote access to remote locations. And networks of today are what we call converged networks or converging networks. prior to any modern era networks, you would have independent networks within your organization for phone, video, data, all of these things individually, and they each require different technologies to carry the signal. And all of these technologies would use different rules and different standards. Not so anymore. In a modern network design, we have all of these existing on the same network. We have data, we have video, we have voice, we have like video voice conferencing too, right? Where it's not just and we've all been using this more and more. Using services like Zoom and Microsoft Teams to face-to-face voice talk with not necessarily just one other person, possibly a group of people, such as a classroom. So converged networks can deliver the data, all of the data, whether it's data, voice, video, whatever, over the same network infrastructure using the same rules and the same standards. This is why we have standards, which we refer to in networking as protocols. We're going to look at that. So network architecture, when we look at how networks are designed, this refers to the technologies that support the infrastructure that moves all the data through the network. And we can analyze our networks and how they're built by looking at 4 different metrics. And all of these 4 things need to be addressed in a reasonable sense if we're going to have a reliable network, i.e., it's secure and it's always up. We need fault tolerance. So we don't want a single point of failure. If we're using a web server to host our web page, well, we're not just going to have one web server. We're going to have at least 2, and maybe more than 2 web servers. So if one goes down, the other can pick up the load. And also, hey, since we have more than one web server hosting our website, we can balance the load across our servers to speed up the availability of our service. It's very commonly done. We need to address scalability. The network should be able to scale in terms of both up and out. Scaling up means taking your networking infrastructure, your routers, your switches, your PCs, and making them better, adding more processors, more RAM, more hard drives, increasing the capability of the equipment that exists. Scaling out refers to in terms of adding more networking equipment, adding more servers, adding more switches, adding more routers. So those are your 2 vertical and horizontal scaling that you need to look at. Your quality of service. You should be able to treat packets that should have higher quality of service, such as VoIP, and sending large files of a sensitive nature like AutoCAD and stuff like that comes to mind. You should be able to not only analyze your network in terms of that, but configure your network to prioritize certain traffic over other traffic. If an email is a little bit delayed getting out, it's not the end of the world usually. If your packets are getting dropped every 10 seconds or less in your video conference, that's a problem, and you need to fix that. So you need to be able to analyze and not just analyze your network for these things, but prioritize traffic for these. And security. I can't stress enough security. We're going to look at some interesting stuff later in the semester. We'll look at a couple lectures on security. But with the migration of everything to the cloud, which is really just somebody else's server or distributed network of servers, security is becoming increasingly more important. You want to make sure your devices are as secure as possible. You've got firewalls, you've got hardware firewall appliances, they're configured properly, you've updated all your equipment so there's no less of a chance of vulnerabilities in running obsolete equipment that's been broken. So you need to look at all these. So we kind of looked at fault tolerance. I talked about all of these off the slide, and here's the slides about them. Fault tolerances, you don't want a single point of failure. So I mentioned web servers, right? You want more than one web server, but also like things like default gateway, right? You want more than one path to get outside your outside of your network. Think about your home network for a minute. If your home router died tomorrow, you're screwed. You don't have any way to get outside. If you were a business, this is bad. That's like end of the world level catastrophe. So modern businesses will have multiple redundant links and alternate paths to get outside of the network. We talked about scaling in terms of out or up, so this is an example of scaling out. We're just simply adding another department here for computers. Scaling up would be if we need to increase this device to add that network port, because you can do that with Cisco equipment. It's modular. Quality of service, I talked about all of this stuff. And network security. So there's two ways we need to look at network security. Well, there's more than two ways, but there's a couple of different ways. There's the physical security. So I shouldn't be able to just walk in and configure your device. And there's also securing the actual information. So if it's going to be sent over the network, it should be sent, if it's sensitive information, in an encrypted format. And I shouldn't be able to decrypt it. A great example about this that I like to tell, usually in my lecture, at some point in the semester, but I'll tell it now. I've got a former professor of mine at Seneca who used to claim that he would walk into a bank, just any bank at random. He'd pick a branch, walk in, with his laptop. He'd walk up to a switch or a router, take his laptop out, plug it into the device to configure it. At this point, keep in mind, nobody has asked him who he is. So that's our physical security sense right here. Somebody should have, said, "Hey, what are you doing?" Right? Nobody's asked him that because he's dressed the part and he has the right equipment, so it looks like he should be there, right? He plugs into the console port. That's the port you use to configure your device, and types in for username and password Cisco and class, because that's the default username and password that's all over the Cisco documentation. I think it's a little more complicated with the newer version 7 curriculum. It's class 1, 2, 3 or something a little more complicated than Cisco and class, but it's not much more complicated. That was just because they increased the password complexity requirements. But regardless, if you're using default configs, and he would walk into a bank and do this and get administrative access to the device, and then he'd go over to the branch manager because he was a nice guy and not wanting to break into their network, and he'd say, "Hey, by the way, first of all, I walked up to that router over there and nobody asked me who I was, and I just plugged my laptop in. And I accessed it and I put in the default credentials that come with all the Cisco documentation, and lo and behold, I had full access to your device. Now, if I was a malicious person, I could have brought your organization down and made sure that there was no work getting done for at least the next 24 hours. I'm not a malicious person. You should get this looked at. And there's jobs that actually you get to do this. It's called penetration testing. So it might be something you want to mull around in your mind and have a look at if you want to analyze somebody's network and try to break in. That's a line of work that pays a lot of good money. As far as securing the network, you want to make sure that only intended recipients can read the data, and it should be encrypted. You have to make sure that the data hasn't been altered or tampered with during transmission, so nobody's injecting false data into your network. And you have to make sure that it's available when it needs to be. And you have backups. And you have backups of your backups. And you have backups of your backups' backups. Like, you can go a little bit too overboard with this, but I think you get my idea. So some more recent trends that are on the rise in the tech industry and in the office environment. When we're actually physically at work, bring your own device is pretty popular. Online collaboration, well, we're doing that right now, so that's extremely popular. Video communication, also very popular. And cloud computing, we're going to touch on each of those kind of individually here. So bring your own device. It allows users to use their own devices. This is the way the corporate world wants to sell it, giving them, the user, more opportunity and greater flexibility. You can bring your own laptop to work and work on that. We don't have to provide you with a workstation. On the flip side of that, we don't have to provide you with a workstation. So you have to provide your own laptop. We're not going to pay for it. Or maybe we'll give you, some money a year towards a laptop, but that's it. And it's your job to deal with. We're not providing a workstation anymore. So there's that side of the coin too. But this does allow people the freedom to use personal tools and communicate using their laptops, tablet, smartphones, netbook, e-reader. Bring your own device means any device with any ownership and used anywhere. Online collaboration. Well, we've seen a lot of this in the last year and a half, and we're probably going to see a lot of it for the next little bit to come, because I don't think we're done with this COVID party yet. It's still ongoing, as much as governments, in certain governments in particular, like to try to claim that it's over and it's done with. No. It's here to stay in some sense, and some people who will have discovered what working at home isn't so bad may want to continue to do so. So there's that. Oops. Just moused over the wrong window there. So we can use online tools like Cisco WebEx. This is an example of using Cisco WebEx, or Teams, or Zoom, or even the virtual classroom we're using at Centennial, I believe, is powered by Big Blue Button, which I use at Seneca, and it's developed partially at Seneca College. All of these tools give you ways to collaborate with others and work over the network, to connect and work interactively in a classroom environment, as we are going to do in our lab class this week and in our future lectures as well. And this is, of course, a very high priority in business and education, and this has been definitely underlined by the pandemic. So WebEx is a good example of a tool. It's kind of like Teams and Zoom, if you've used either of those. It's a multifunctional collaboration tool. You can send messages, you can post videos, you can post images and links, you can meet for things like this. Teams is Microsoft's equivalent of that, and there's others out there as well. Video communication can be made to and by anyone, regardless of where they're located physically in the world. As long as you have an internet connection and a device that you can video call in, you could video call from your toilet if you wanted. I don't recommend it, especially in a job interview, but you could. I will not do that while teaching class. Just as an aside, I have a kind of like an office area with my desktop set up downstairs, and that's where I am. You're probably not going to see me over the webcam over the course of our semester, but I'll show you a picture of me in our class together. Just because it's an early morning class. I probably rolled out of bed, and I haven't showered or dressed or anything of that fun stuff, and made myself look pretty for the camera, because I'm at home, and I'm sure you're learning just the same. This is a powerful tool that can be used for communicating with others, like right now, and it's become critical for effective collaboration. If anything else, the pandemic has underlined our need for stable work-at-home video conference and remote access. You can also use Cisco Telepresence Powers, and that's one way of working with everyone everywhere. Cloud computing, another rising trend in networking. And there's a lot of different terms to describe this, but you're working on somebody else's network, either on their server or their distributed cluster of servers. Depends on the company. Well, it's not just going to be one server, but that's all the cloud is. A fun joke I like to tell here is there's a kid and his dad out for a walk talking, and the kid turns to his dad and says, "Daddy, what are clouds made of? The dad answers with Linux servers, mostly. And that's true. Linux powers a lot of our cloud infrastructure that we use globally. A lot. Even Windows Azure, or Microsoft Azure, which is Microsoft's cloud. If you launch a command line within Azure, it's a bash shell, so a Linux shell. So even that is running on Linux. And they've recently released an open source out in the world release of their edge security network that they use for Azure, their operating system for that, and it's Linux, which is kind of crazy. You can't do too much with it, but it's interesting. So cloud gives us the ability to store personal files and back up data to our servers and connect to everything, and even run virtual machines and virtual desktops and stuff like that over the internet. You don't necessarily have to have a device in your house to do that now. You can just connect to a cloud provider and fire up your VMs and do whatever you need, and it's there. It also allows businesses to deliver content to any device anywhere in the world locally as if they were actually there, which is kind of crazy. This is made possible by data centers, and smaller companies that can't afford to build their own data centers, well, they work out a deal. They don't work out a deal. They subscribe. They lease storage and server services from cloud providers, which, Windows Azure, Microsoft Azure is one of them. AWS, which is Amazon's cloud. Fun fact about that, it actually originated from Amazon building their own infrastructure, and then they realized, hey, we could make some money off this, so let's build it bigger, and let's start selling service to people. And so that one came about. And there's others out there. There's quite a few others out there. Those aren't the only ones. Google has a cloud out there as well. It's not as commonly used. Cloud computing falls into a couple, four different types. Public cloud, so these are available to the public on a pay-per-use model or completely for free. An example of this, of course, is AWS or Microsoft Azure. Private clouds, so these are intended for specific organizations or governments, and they tend to be built by those organizations. Hybrid cloud, which a lot of companies use, they're made up of two or more cloud types, so usually a combination of private and public. Some resources will exist in the public cloud, some resources will exist in your private cloud, your own custom-built data center, and you'll deal with passing information between these servers that exist in these two different frameworks in some way. Remind me later in the semester, someone please. I have an interesting video about a couple developers from Blizzard actually talking about how they use OpenStack for their own public cloud or private cloud and a public cloud provider, and they run a hybrid cloud configuration for the servers that power StarCraft 2 and Overwatch. I think in that particular one they're talking about specifically Overwatch, but I know for a fact that that technology has been expanded to all of their games, even World of Warcraft. And then you might have custom clouds as well, so these are built to meet specific industry needs. Healthcare and media tend to be the major drivers behind these, and these can be either private or public. We're talking about technology trends. Trends. It's been a long day, I apologize. So smart homes are one of the growing technologies. You can have various smart appliances in your home, everything from a smart light bulb to a smart toilet. I'm going to make a joke, I'm sure, somewhere in the semester about smart toilets, and they do actually exist. So when shit really does hit the fan, you could have smart ovens. These exist too. I don't think it's crazy, and the more I learn about IT, the less I want these devices in my home. But with a smart oven, you can program it to preheat at a certain time to cook a meal for you. And you might even be able to automate this by connecting it to a calendar or schedule when you're going to be home to do this. I know there's one out there that has an app on your smartphone that you install, and you can actually preheat your oven from your smartphone as you're driving home, which is kind of crazy. There's all kinds of different things being done in smart technology, particularly home-focused stuff. You can have smart light bulbs, so you can have them set to go on and off at a certain time, but you don't actually set like the individual light bulbs. You connect them to the network. You connect the server to the network, and the server controls all that stuff. You can even have smart heating and air conditioning, where it's designed to keep the house at a certain temperature. You program that in on your server again, which you tend to interface with through your smartphone. And if it falls outside of those parameters, it'll turn off the heater, fire up the AC, or vice versa. All kinds of crazy stuff going on here. You can have power. So they call this power line networking, power over Ethernet. This allows you to connect devices over a network or across a large demographic, a large area, or even just like a tricky area where you can get a wireless access point up there. This is where these tend to be used, but getting power to that wireless access point is going to be a problem. You can use power over Ethernet, and then the medium that's connecting your access point to the LAN is also providing power to that access point. And there's growing trends in this as well. And wireless, we got lots of wireless stuff. Like everything's wireless. Smartphones. Some people want wireless as a broadband service now to all their devices, not just what we have now. Security, I do promise we're approaching done, which is good because we're getting up there in time. You're going to notice this is a fair bit shorter than what we would have normally in a 2-hour lecture. I usually don't fill the whole 2 hours, but I give you a good hour to an hour and a half. This has been sped up a little bit, of course, by not having to stop for questions, which recording videos and delivering content asynchronously takes that into consideration. So security threats. Network securities become extremely important, especially as we migrate more and more resources to the cloud. So this has to be taken into consideration from design up. And you have to secure the data. You have to secure the data as it's in transit over the network. And you have to, this is a tricky thing, you have to still allow users to do what they need to do. So you could secure everybody and nobody can do anything. The best way to secure a network, unplug your device from it. You want to secure a server, unplug your server. That's 100% security. Nobody's going to hack into that server. The downside is nobody can access that server and no traffic can get from that server at that point. So we go through various different methodologies to secure it, and we're going to look at this later in the semester. We'll look a little bit about it in the next couple slides, but we look at different protocols, technologies, devices, tools, and techniques to secure data and mitigate threats. And threats could be external threats. They could also be internal threats. Always keep that in mind. Types of external threats, things like viruses, worms, Trojan horses, spyware, adware, zero-day attacks, threats performed by somebody who's trying to hack into your network, denial of service or distributed denial of service. You've all heard of these DDoS attacks. DOS is denial of service, of course. Data interception and theft, identity theft. And internal threats, you tend to get lost and stolen devices, accidental misuse by employees, intentional misuse by employees, and just malicious employees in general. Really, your people are your biggest threat. We're going to look at all of these in more detail later in the semester. So when you're developing security solutions for networks to try to secure your network against all of these threats. There's a couple important concepts to keep in mind. Security is a constant process, first and foremost. There is no single security policy or protocol or device you can put in place and say, aha, my security is impenetrable now. My network is unhackable. You have to constantly analyze for threats, analyze your network for weaknesses, and fix those as they come up. It's a cycle, and it's a never-ending cycle. Security, much like an ogre and an onion, has layers. If you've seen Shrek at all, you understand that reference. Onions have layers. Security has layers. You want to layer on as many possible security measures and hope to try to prevent access. So things like having hardware firewalls is a good security layer. Having access lists configured on all your devices. Having software firewalls configured on all your servers. Making sure that all your end devices are secured with antivirus and anti-spyware and anti-malware. So layering all of these things, and there's also various other devices that we can layer on, such as an IPS or an IDS. So IPS is intrusion prevention system, IDS is intrusion detection system. And for remote access, you want a secure remote access, you're going to want to configure a VPN. A VPN will allow you to connect to the local network from an external source with a fully encrypted connection end to end. So those are kind of some of the things that you want to look at. But really, before you do any of that, you need to learn what a network is and how to configure it. And that's what we're going to look at this week. We're going to look at configuring a router and a switch. Basic stuff. Start at the beginning. The rest will come later. We're approaching the hour mark, and I'm right at the end of my slides. That's the last slide. That's kind of a good place to finish off on. Don't be afraid. We're going to start from the beginning, and we're going to teach you everything we need to know this semester. Thank you for watching. Take care. Be safe. Have a wonderful day, and I will see you in our next class. If it's tomorrow's lab class and you've managed to watch this the night before, awesome. If it's after tomorrow's lab class, which I'm expecting is going to be more likely, then hopefully you're watching this before we meet next week for our lecture, and you'll have some questions for me then. Take care. Be safe. Bye for now.